All right, let's sketch the last graph here. This one is not in factored form, so we're going to have to use synthetic division. Our possible solutions. Oh, I've had to sneeze for a while, all through the last video. All right, possible solutions are the factors of the constant, which is the 4, or technically the negative 4, divided by the factors of the leading coefficient, which is the negative 2. So our possible solutions are, so the factors of 4 are just plus or minus 1, plus or minus 2, and plus or minus 4. The factors of 2 are plus or minus 1 and plus or minus 2. Right? So it doesn't matter whether it's positive or negative, right? We can divide evenly a positive number or a negative number. If we divide by 1, that's going to be plus or minus 1, plus or minus 2, and plus or minus 4. If we divide by 2, 1 divided by 2 is a half. 2 divided by 2 is still 1. 4 divided by 2 is still 2. So we've got 8 possible choices, but we can't use the 1/2 or negative 1/2 with synthetic division. So we're going to have to just use those 6 integer values. I guess, they're all even. Oh, yeah, I could factor out the 2 if I was thinking about that. So I could factor out the 2. It's not really all that essential. So I suppose I will leave the 2 in there for now. And we will, let's choose 2 since they're all even, and see if that's a solution. So I have a cubic term, so that's negative 2. I'm missing the squared term, so that's 0. I've got an x and I have a constant. So bring down the negative 2. Negative 2 times 2 is negative 4. Add, we get negative 4. Negative 4 times 2 is negative 8. Add, we get negative 2. And, oh, so close. Negative 2 times 2 is negative 4. And that doesn't work out. So, but we were close. Let's try negative 2. I'm not going to save this because I'm going to run out of space. So you don't have to write it down. Let's try negative 2. All right, let's bring down the negative 2. Negative 2 times negative 2 is 4. Add, we get 4. 4 times negative 2 is negative 8. Add, we get negative 2. Negative 2 times negative 2 is 4. Add, we get 0. So we have negative 2x squared plus 4x minus 2 equals 0. Let's take care of that negative. Let's factor out a negative 2. And that'll make the factoring easier if this is factorable. And that'll be x squared. And 4 divided by negative 2 will be a negative 2x. And negative 2 divided by negative 2 is a positive 1. Well, this is a really easy factor. So multiplies to give me 1, adds to give me 2 is, and here, let's get rid of the negative 2. Ta-da, gone. So we're going to factor x squared minus 2x plus 1. All right, multiplies to give us 1, adds to give us negative 2. Of course, is negative 1 and negative 1. So x squared minus x plus a negative x and plus 1 equals 0. First to our group, second to our group. We could pull out the x. We have an x minus 1. We could pull out the negative 1. We have an x minus 1. And so factored, this is x minus 1 times x minus 1, or x minus 1 squared. All right, so by the way, this is a perfect square. Right? And so maybe we'll review some rules so that you don't actually have to go through the steps of factoring when you see a perfect square. We've got 2 distinct solutions. We have the negative 2. And then we have the 1, right? If we set x minus 1 equal to 0, x would be 1. and that one is multiplicity 2. The y-intercept is easy to figure out, right, because it's in standard form. Our y-intercept is 0, negative 4. So we've got our y-intercept, we've got our x-intercept, we've took up a tremendous amount of space. And I don't know where we're sticking our sign chart. I think I'm going to extend the page a little. And I'm going to erase this part here. I don't think that's all that crucial. So if you just want to put that right here, just the factoring, because it was a perfect square. I think we will take that out. All right. And now let's do the sign chart right below our graph. I have the numbers, the scale changed. I don't know if I need it or I just changed all of them. I think I dealt with the only one that had a scale that didn't fit. So negative 2 and 1. So we need to know what happens when x is less than negative 2. Between negative 2 and 1. And for x greater than 1. All right, so for x less than negative 2, let's take negative 3. And I'm going to use what's called synthetic substitution. So my remainder is the value of the function, and then I don't have to bother plugging it in. I find this faster. So bring down the negative 2. Negative 2 times negative 3 is 6. Add, I get 6. 6 times negative 3 is negative 18. Add, we get negative 12. Negative 3 times negative 12 is a positive 36, so that's going to be a positive 32. So we are positive here. We already know one of the values. We know the y-intercept. So we know this is negative because our y-intercept is negative 4. And let's just the only other value to check would be a negative 1. Let's just kind of mentally check the negative 1. Because that's a pretty easy number to figure out in your head. Negative 1 cubed is negative 1 times the negative 2 is a positive 2. So f of negative 1 would be a positive 2. 6 times negative 1, that would be a negative 6, and then a negative 4. So that actually is more extreme, not by much, but this would be negative 8. So that's going to be our relative extreme value. We did get a more extreme value for negative 1 than we did for 0. So this will be a relative minimum. It is the only extreme value because we have only 2 distinct x-intercepts. We do need to figure out what happens on the other side and plug in for a value, greater than 1, not 1 though, greater than 1, like 2. So negative 2, 0, 6, negative 4. Bring down the negative 2. Negative 2 times 2 is negative 4. Add, we get negative 4. Negative 4. 2 times negative 4 is negative 8. Add, we get negative 2. Negative 2 times 2 is negative 4. Add, we get negative 8. And we are still negative. We didn't change. Well, if you remember, that 1 was multiplicity 2, right? So we're not going to change signs. So that's a good sign we didn't change signs. We would have something is wrong if we change signs. I don't think we need this change the scale though. I think we can just graph, which is nice. All right, so let's graph our points. So we have our x-intercepts at negative 2, 0 and 1, 0. We have a y-intercept at 0, negative 4. And we have an extreme value at x equals negative 1, and that was negative 8. So something other than our intercept, our y-intercept. All right, so I haven't talked too much about the shape of the graph as we've been graphing these. Just as a reminder, So let's just go back and review shapes of graphs before we hit this one. So if you're cubic, I've got 3 solutions here. This is a cubic function. I've got, and each one appears once. So, and I have a positive, our leading coefficient is positive. You will be shaped like this. If my leading coefficient was negative, I'd be shaped like this. Right? And actually, we're going to see one because we're going to be graphing one like that. All right, so the second one is 4th degree, right, because we have one solution 3 times and the other solution once. All right, if, and my A here is less than 0, so you're shaped sort of like an M. In this case, though, our M only has one little hump because we only had 2 distinct x-intercepts. So here, we're cubic, and our starting value is negative, right? So A is less than 0. And that means we're going to be shaped like this. So the 4 basic shapes at least tell you where to get started. So I should not start from below. I should start from above. Plus, we know that for values greater than -2, we're positive. So we're above the x-axis. So I should be starting from above. So we're going to start from above. Let's see, we have the 2 is multiplicity 1, so we will cross. We will go through our turning point. We'll turn around. We'll hit the y-intercept along the way. And then this is multiplicity 2, so turn, 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 turn. And there we go. And you can see we have that same shape as we just sketched out just to give us an idea of the shape of our graph. All right, let's fill in the last interesting pieces, which are the domain and range, increasing, decreasing, positive, negative, and behavior. Everything we could possibly analyze. So f of x is greater than 0. We're above the x-axis just for -infinity to -2. Everywhere else, right? So this is where we're above the x-axis. Everywhere else, we are below the x-axis. So f of x is less than 0 for -2 to 1, and then again from 1 to infinity. I'm going to get a darker color to write with. All right, and then we're increasing. Right, where the y values are getting larger. There's only one place where the graph is increasing, and it's right here. So f of x is increasing from so our turning point's at -1. -1, and our second turning point, right, so this is one turning point, -1, -8. The other turning point is at 1, 0, our repeated x-intercept. So we are just increasing between -1 and 1, and then everywhere else decreasing. Domain and range, that's easy. All real numbers for both. It's cubic. And the last little thing is end behavior. All right, so here we approach infinity as x approaches -infinity, and we approach -infinity as x approaches infinity. All right, so as we look to the left, right, our graph is getting larger. As we look to the right, our graph is getting smaller. And that's everything. So thanks for watching. Bye for now.